Hello everyone, this is James Shore with another how-to video. I'm recording this on October 2nd, 2015. For the last several chapters, we've been working on getting our test and build automation set up, and as of the last episode, we finished our final chapter on that infrastructure, and now we have a lovely set of automation. Everything is good to go. So now we're going to start a new chapter focused on test-driven development. In this chapter, we are going to look at the fundamentals of test-driven development and how to use it to create high-quality, tested, and well-documented and well-designed front-end code. Let's start out by reviewing what we have so far. In the last several chapters, we did put together just some amazing infrastructure. What we can do now is, with one command, we can start up a test server called Karma. I run Jake Karma. Jake is our build script and our build tool, and that will run the Karma server for us. The Karma server is what allows us to test our code in real browsers. So now I can come over to Firefox and I can point it at localhost 9876, and it will connect to Karma, and any test that we run on the command line will actually run in the Firefox browser. And not only do we run it in Firefox, we also have the ability to connect multiple browsers. So we have it set up with IE9, IE11, Safari, Firefox, and even the Android running in the Android simulator, and iOS running in the iOS simulator. So now we've got all these browsers running, and anytime we run our tests, they will run on all of these browsers simultaneously. And that, of course, is automated as well. If I go over to a new tab, I can run Jake. Our code will lint everything to make sure we don't have any common mistakes, and then it will run our tests in all of those browsers. We also have it set up so that with another command, Jake run, we can run a local server so that we can look at our website as it would run on a real production server. And here is our Hello World app. In addition to this, we have set it up with modules so that we can split our JavaScript among multiple files and still have everything work. And that has all been accomplished over the last many chapters. Now what we're going to do is look at test-driven development. In this episode, we're going to go over the fundamentals of test-driven development. So you see here we have our two test files. We have addition test and addition. And as you'll recall, this is just a really silly, simple little example to demonstrate concepts. And we're going to continue with this in this episode, but very soon now we're going to start moving into our real tab-based application, our front-end application. When you're doing test-driven development, you're going to follow a common pattern typically referred to as Red Green Refactor. Now, before I explain this pattern to you, something you should know about test-driven development is that test-driven development isn't really or just about testing. It's really about providing you with lots of feedback as you do your development so that you can develop high-quality code. It's a way of working in baby steps, in micro steps, so that at every step of the way you're in control of what you're doing and you understand exactly how your code is working. Because as you work in more and more complex programs, what you're going to find is that it can be really easy to lose track of what's going on and get to a point where the code doesn't work and you don't know why. And that leads to expensive and time-consuming debugging sessions. If you do test-driven development well, you should find that you very rarely need to do any debugging. Whenever something doesn't work, it's going to be because of a line of code you added just moments ago, and you'll be able to look at that line of code and figure out what went wrong in most cases. And when you can't figure it out, you'll just back up and try something else. So baby steps is the key to test-driven development. It's a way of driving the development of your code. The driven development is more important than the test. Driving the development of your code in tiny little steps that you can confirm work every step of the way, using tests as the engine. Now, the outcome of test-driven development is a bunch of tests that you can use for regression testing. That is, you can run them over and over to make sure you haven't broken anything in the future. So test-driven development, in addition to having the value of helping you drive your development of your application, also has the value of providing a really nice suite of tests. And it also has the value of, when done well, providing documentation to others about how you intended your code to be used. So there's lots of benefits to test-driven development, but as you're learning it, as you're working with TDD, the thing I want you to remember most is that it's not about the tests. It's about what you learn and how you remain in control of your code as you use tests to drive the development of your code. So that's TDD. It consists of 5 steps, typically shorthanded as Red Green Refactor. But the very first step is actually the most important, and it's not included in that little mnemonic of Red Green Refactor. The most important step, number 1, is think. And I'm not just joking here. It really is. What you're going to do in test-driven development is a little backwards. You're going to use your test to control what you write in your program. And that backwards thinking for beginners to TDD, for people new to TDD, that's a brain bender. So don't forget step number 1. Spend as much time as you want on step number 1. Think about what bit of your program you want to write next. So number 1, think about what you want to do, and then what test you could write that would force you to write that code. See, that's the backwards part. What test can you write that will fail until you write the code that you want to write? And what test will only fail until you write just that little tiny bit of code? Then you'll write that test, and you want to work in really small steps here. So when I say think, I mean think of some code that you want to write that's less than 5 lines, and a test that will force you to write that code that is also less than 5 lines. That's the hardest part of this, by the way. Then you write that test, and it will fail because the code doesn't exist yet. That's the red part. Then you write the code to make the test pass. That's the green part. And then you look at the code you've written so far, and you ask yourself, is this the best code I know how to write today? Can I make this any better right now? And if you can see any way of making it better, then you make that change. You refactor your code so that you're not changing the way it works, but it's written a little bit better. And you keep doing that. You repeat the refactoring until you've made all the improvements you can think of right now. And then you repeat the whole process over again. Think red, green, refactor, maybe some more refactoring, and then repeat. Think red, green, refactor. Something that is often surprising to people who are new to test-driven development is that the most effective practitioners of TDD are capable of taking very small steps. You might think that as you get good at this, you'll take bigger and bigger steps. But actually, the hardest part of TDD is figuring out how to break your work down into tiny little steps that you can confirm in baby steps. So work hard to think of tests that are less than 5 lines of code and production code that is less than 5 lines of code, and take those really small steps. And as we go through this, I think you'll see that we're taking really small steps. And my challenge to you is, as you do your own work, to also figure out how to take those very small steps. This TDD cycle, think, red, green, refactor, repeat, this can be a pretty fast cycle. This is the fast spinning engine gear that drives everything else you do. So when you're in the groove, you might write a test in 30 seconds. You might write the production code in another 30 seconds, and then spend a couple minutes refactoring. You won't refactor every time through the loop, but when you do, you might spend a couple minutes refactoring and then go through it again. Don't worry too much about how fast you're going, though. Instead, focus on really small steps and making sure that you get to the red, the green, and then when you refactor, you stay at green. All right, enough soapboxing. Let's actually demonstrate this. So I'm going to stick with our silly little application here. Step 1 is think. What code do we want to add to our addition.js? Well, for me, I'm thinking we're going to want a subtraction code. So I want to write exports.subtract. But wait, this is the backwards thinking part of TDD. We're not going to write that code now. We're just going to imagine it. We want to write a function about subtraction. So imagine in your head what that will look like. And now think to yourself, what test could we write that will force us to write those lines of code? Think about that for a moment. Now that you've thought about it, think about how can you do it in even smaller steps? And what test could you write to force you to think in even smaller steps? Well, for me, what I'm thinking is that we've got two pieces. We want to write the subtract function, and we want to write this line of code. It's going to be a minus b, right? We could actually break that apart into two steps. And for the purposes of this example, I'm going to go ahead and do that. Although I have to admit, in practice, I usually don't go quite that small. So what code can we write that would force us to write just this line in the closing bracket? What test could we write that does that? Well, if we call a function that doesn't exist, we'll get an error. And errors, an exception, will cause our test to fail. So let's go ahead and try that. I'm going to just write a new describe block. Remember from our episode on Mocha that our tests in Mocha are grouped into describe blocks, which then have individual it statements that are the actual tests. So I'm going to describe subtraction. I'm going to write a test in here that says subtracts positive numbers. Or rather, no, what we're trying to do is just see if there is a subtraction function. So what we're going to say is subtraction exists. And to make this test fail, all we need to do is say addition dot subtract. That alone should be enough to make this fail. Let's give it a try. I'm going to kill our localhost server here and run our tests. Look at that, it's failed. Now, because I've got all these different browsers running, we're seeing the error come out over and over again. And that's a little frustrating. That's just a feature, a misfeature of Carmen, that it doesn't provide really great output. But normally you can just look at the last failure, whatever it is. What we see here is addition.subtract is not a function. So first we thought about what we were going to do, and then we wrote a test to make it fail, and we got to red. Now we need to write the production code that will make this test pass. Just enough to make it pass, though. Again, the hard part here is taking small steps. So what can we write that will be just enough to make this test pass? This step usually won't be that hard because you've been thinking about it already. And in our case, we know that just writing the subtract function and nothing else, not even the parameters, that should be enough to make this pass, enough to get green bar. And there we go. It's called green bar, by the way, because some testing tools will actually display your progress with a little GUI progress bar. And that bar will be green when the tests are passing and red when the tests are failing. So even though we don't have a bar, we do have red text and green text. And because it's just the way people talk about it, I'll call that red bar and green bar. So we've thought about what we want to do. We've written the test to make it fail. We've written the production code to make it pass. And now we're going to refactor. We're going to look at our code and say, is there any way to make this code better? Well, honestly, yes, there is. I do see a way to make this better. We're calling this addition, but we're really no longer about addition. What we're about here is arithmetic. But I don't want to do that rename right now because I think it would distract from what we're trying to do. So I'm going to take out a note card and I'm going to write down on it, rename addition to arithmetic. And I'll come back to it again later. The important thing here isn't that we do the refactoring every time, but that we think about it. Some things that we'll see an opportunity to refactor right away. Other things we'll come back to at a more convenient time. And some things we'll identify and then decide aren't worth doing right now because we've got more important things to do. That's a judgment call that you'll just have to make as you work. Now, since you can't see an index card in front of me, I'm going to go ahead and make a to-do file here, right at the top level. And I'm going to say rename addition.js to arithmetic.js. And when we do that, we're going to want to rename our addition variable here in addition test. We're going to want to rename that to arithmetic as well. Now, when you see these opportunities to refactor, don't write them all down. It's often best to take advantages of the opportunities right away, but there are going to be some things that are a little bigger that you're going to want to wait on. All right, that's our refactoring. Now let's go ahead and go through the cycle again. Think, what do we want the code to do next? Let's look at our addition.js. What are we not yet doing in this code that we really ought to be doing? Well, I don't know about you, but I'm thinking maybe actually subtracting some numbers might be a good idea. So that's the next productive step I want to do. I want to write some code to force me to write that subtraction. It's going to look just like this. It's going to be return a minus b. So what test can I write that will force me to write that line of code? Personally, I'm thinking calling addition.subtract and seeing that it actually subtracts. So let's change our existing test. You don't always have to, sometimes as you work, you'll write a test that doesn't stick around because it's not meaningful enough. So I'm going to change this test to be subtracts positive numbers. I'm going to change this to be 10 minus 3. And I'm going to return that result into an actual result. Now our expected result is going to be, well, 7, or 10 minus 3 in this case. But I think I'll just write that as 7. So we've set up our expected result, we've done the subtraction, and now we need a way of running the test. If we run this test right now, it's not going to fail, I don't think. Let's give it a shot. No, it's not going to fail. We need an assertion. So let's assert that we expect the actual result to equal the expected result. And that should fail. So that should give us our red bar. 3 lines of code, nice and small. Let's run that. We should get a red bar. And we do. Let's make sure it's giving us the right answer. It's saying expected undefined to equal 7. Now, as you're going through this, think about what result you expect each time you run the tests. Did you expect undefined to come out? Well, I did, because subtract doesn't return anything. Now, I could prove that I'm right by returning, minus 3 here, just for the sake of example. And then if I ran this, I would expect minus 3 to equal 7. And that's exactly what we get, expected minus 3 to equal 7. So what this means is by making a little prediction about how the test run should come out, what you're doing there is you're remaining in control. And if you run a test and you're expecting a red bar and you get one, but it's a different error than you expected, take a moment to figure out what went wrong. Because remember, test-driven development is about taking micro steps, little baby steps that allow you to prove that you know that you're in control of the code, that you can keep track of what's going on in your code every step of the way. So this is failing in the way we expected. Now we need to get to a green bar by implementing the code. That's really easy. We'll just pass in an A and a B and return A minus B. And now when I run the test, I expect to get a green bar. And there we go. So we've thought about our test. We've implemented the test. We've made it pass. So think red, green, and now it's time for a refactor. Let's take a look at our code. Are there any opportunities to improve our subtract function here? Well, honestly, I don't see any. This is really straightforward. Well, no, I take it back. I do see one. There's an extra blank line. I'm going to delete that to be more consistent and to be a little bit prettier. So there, one refactoring. Often you'll run your tests again after refactoring to make sure you didn't break anything. Although often if I'm just cleaning up code, I won't necessarily run the tests right then and there. And then here in our test itself, well, I see another couple of blank lines that I'm going to delete. And I'm not really worried about that breaking it, but I'll double check. Yep, we're still good. And This test is a little bit verbose, so we could make this better. We could combine it down into one statement like we have for these other ones. I think I am going to do that refactoring, but before I do, I want to point out something to you. When you're writing your tests, you're typically going to follow a really common pattern called arrange, act, assert. And that's what you see here. First, we arrange our expected values and any other setup we might need for our production code. Then we act by calling our production code. And then we assert by comparing the values. These three steps will happen in pretty much every test you write. So keep them in mind. Arrange, act, assert. That said, this is awfully verbose, and this is a very simple problem, so I'm going to combine them all together. I'm going to take our expected result and inline it by moving the 7 in place of the expected result variable. That is the inline variable refactoring. And that should still pass. And it does. And then here, where we've got actual result equal to this, we only use this actual result variable once, and it's not that complicated, so I'm going to inline that as well. I'm going to take this, cut it out, and replace it here. So now we're asserting that the result of addition.subtract 10, 3 is 7. Now, is that better code? In my mind, it is. It's nice and pretty. It's compact. But it's a little harder to understand. You have to spend a little more time puzzling it out. So is that actually better? I don't know. That's your call. As the programmer, your job during the refactoring step is to make the code the best you know how to make. What's best is very much a judgment call. If you do pair programming, it's really useful to have that, to talk it over with the person you're programming with. That's one of the major advantages of pair programming, is you do end up with better code. But if you're working alone, just take your best stab at it. The thing about refactoring is that this form and what we started with are equivalent. Whether one is better or not is purely a matter of taste. And I'll leave that to you to decide. After doing the refactoring, we need to test to make sure that everything worked, that we didn't break anything in the refactoring, and sometimes you will, believe me. But in this case, we didn't. So that is test-driven development. First, think about the code you want to write next and what small bit of that you're going to do as your next baby step, and then what test you can write, what small test you can write that will force you to write that code. Then write the test, get a red bar, make the test pass, get a green bar, and then refactor. Improve the code so that it is the best code you know how to make, given the time you have available and using your own judgment about what good code looks like. Refactor, repeat that refactoring until you can't see any more ways to improve it, and then repeat the test-driven development cycle from the beginning. Think, red, green, refactor, repeat. Next time, we're going to start looking at what it takes to do test-driven development of front-end code. So far, all we've been doing is test-driving simple addition functions that don't really depend on anything about the browser. Next time, we'll get into that and start looking at the document object model, the DOM. Your exercise for this time is to repeat what we've done so far. Write your own subtraction test and subtraction method, or function in this case. And as you're doing it, practice taking those really small steps. It's going to feel silly to take such small steps, to write the function without anything in it before you write the actual implementation of it. Practice that anyway, because that is the most valuable skill you will learn in TDD, and one of the hardest. As we get into more complicated problems, taking those small steps is going to be very valuable. For those of you who are more advanced, go ahead and finish the addition refactoring that we didn't do. Rename addition to arithmetic and rename it in the addition test as well. And then test drive some more mathematical functions. Think about what else you could do in your arithmetic, or maybe you want to call it math file, and what kinds of algorithms you could implement and test with test-driven development. Things like sine or cosine or square root might be useful. And try implementing some functions that take more than just one line of code and figure out how to do them in really small steps. That is a skill that will take, well, frankly, a lifetime to get good at. I still constantly learn new things about how to do test-driven development. And a lot of what I learn is about how to take small steps and how to make my code really readable and clean. That's it for this time. Thanks for watching, and I will catch you next time.